Hello everybody. So in the last class we have already done about the Debroglie thing. We have already understood what is Debroglie and all. So we have known that Debroglie is all about material or matter waves. That is, Debroglie argued that as all the radiations have dual nature, that is they have also particle nature, similarly all the material or matter will also have wave nature. Now today we will be doing de Broglie equation. So de Broglie equation, first of all we have to do something. Again we will start with Einstein's mass energy equivalence, which we all know is basically E is equal to mc square, known to everybody, nothing new. And also you have known that for a photon, so whatever I am doing at this point we are doing for a photon, and we know photon is a particle, it is a small packet of energy. So for photon E is equal to mc square, we know. Now we also know from Planck's quantum theory, Planck quantum theory, what do we know? That each packet of energy, that is each photon, will have energy is equal to Planck's constant into frequency of that radiation, correct? Now if I equate this to, before that I'll do a little bit manipulation. What is it? Frequency of the wave. I can easily write this velocity of light radiation by lambda. If I can write this, then definitely at this point of time I have this equation 1, I have this equation 2. Now I am going to equate equation 1 and 2 to get mc square is equal to hc by lambda. Lambda is wavelength of light. Now from here you can easily manufacture something, right? What we can manufacture? One of the c gets cancelled out. So see, if I bring this lambda to the left hand side and take this mc to the right hand side, so this mc will come in the denominator, h by mc. So this is nothing but momentum of the photon. So lambda is equal to momentum of the photon. This derivation is for what? This derivation is for photon. Clear? This derivation is for photon. So everybody of us will agree with the derivation. Now de Broglie argued with his hypothesis that if this is the formula of wavelength, that is h by momentum for a photon which is a radiation, then definitely matter is also going to have similar kind of formula for its wave nature, that is for any matter wave. So what did de Broglie say? After this, de Broglie said for matter lambda, which is nothing but de Broglie wavelength. Many times it is asked, de Broglie wavelength will be equal to h by mv. So what did de Broglie do? De Broglie bought this equation of lambda for photon and used it in case of matter also. Now what he argued is that for matter it can be electron, proton, which we already know are nothing but particles. So this equation is equally valid for electron, proton, neutron. So for any matter it is valid, what de Broglie said. Okay. Now I am writing only electron, proton and neutron, and maybe there are some other particles which I am not writing at this point of time. But electron, proton, neutron, the three subatomic particles I am writing. But I am not saying that it is having an example as, suppose I am not taking myself as an example, I am not taking a ball as an example. I am taking the examples as electron, proton and neutron. So there must be some reasons to it. However, these are particles, these are matter, this is going to follow the same formula as per de Broglie. Now we will come to the next question. Sorry. Now, if I write lambda de Broglie is equal to h by momentum, from here I can write lambda de Broglie is inversely proportional to momentum. So if it is inversely proportional to momentum, it is also inversely proportional to velocity of that particle, electron, proton, neutron, whatever, it is inversely proportional to that. Okay. Now from here I can say if velocity is 0, then what is lambda de Broglie? Lambda de Broglie is infinity. Now what does this actually signify? Many of you can say infinity is very long and all stuff, but what does this signify? Let us see one thing. What is wavelength? For a wavelength, for a wave, the wavelength is this, right? This is the wavelength. Everybody of us know that this is the wavelength for a wave. Clear? Now, if this is the wavelength, then if I increase the wavelength, I will make this kind of wave. Now say this is lambda 1. Now I again increase the wavelength. Okay. Sorry about this. So as the wavelength is increasing, so it is going there lambda 2, we can see as wavelength increasing, as the wavelength is increasing, the wave is losing its wave nature. The wave is losing its wave nature. Suppose this wave goes like this. This is the direction of the wave, there is no amplitude, amplitude is 0. Then in this case, you are not going to say that this is a wave, you are going to say this is a rectilinear propagation, this is not a wave. Okay, so that is what it signifies. Whenever the velocity is 0, then lambda de Broglie is infinity. That means lambda de Broglie or wave nature of a matter is not applicable when velocity is 0. Why? Because that time it is not going to show wave nature. You can write this, what this signifies, no wave nature. This is very important, huh? Okay, up to this it is okay. You can write this directly also, but you need to put some head into it, that why this is no wave nature. The reason is over here. So I hope I am able to explain it to you why it is showing no wave nature. Clear? Now coming to the next part. Next point is de Broglie waves. Are what? Are basically waves associated with matter. So I'll write it matter waves. I'll write it matter waves. Now when I'm talking about matter waves, there can be two kinds basically. Okay, One is this matter can be uncharged, another is this matter can be charged. This matter can be uncharged, this matter can be also charged. Both are possible. Like for charge it can be proton which is having positive charge, electron which is having negative charge, neutron having no charge. So when you are talking about matter, then it can have charge, it can be chargeless or neutral, okay, uncharged. However, if we are talking about electromagnetic waves, what are electromagnetic waves? Electromagnetic waves are basically charged species. These are charged species in acceleration. If there is no acceleration or there is no charge, then we cannot call that an electromagnetic wave. That is the origin of electromagnetic wave. It is due to the electric field and the magnetic field which is causing acceleration. And see, electric field can cause acceleration only in case of charged species. If it is uncharged, how the field will work? Basic fundamental, okay. So that is why it is associated with charged species. However, de Broglie waves can be associated with uncharged and charged species. So you need to remember one thing: de Broglie wave are not matter waves, are not, sorry, electromagnetic waves. De Broglie waves are not electromagnetic waves. Clear? So that is what de Broglie waves are. So each and everything you need to go in little bit details, so that any question that comes in your examination, questions are not always numerical type. Questions are not always that they will give you problems. There can be conceptual theoretical questions also, because you need to remember one thing: whether it is a theoretical question which may be requiring maybe 1 second, 2 second, 3 second, whatever, it may be a numerical type, that is a problem sum, which will maybe take 5 minutes of your time, but both the questions will earn you 4 marks. The value is same for you, so you need to do each and everything very precisely, okay. Next, we already know that de Broglie wavelength is inversely proportional to momentum. So from here I can say it is inversely proportional to mass also. So suppose if mass is less, suppose if mass is less, there is not much of a mass, it is a small mass, okay, then what happens? If it is a small mass and if it is a large mass, then what happens? Both the thing we need to understand. So one case is mass is less, another case is mass is large. So when mass is less for subatomic particles, correct, electron, proton, neutron, this kind of things have less mass. Mass is large for, say, a car, a bus, cricket ball, etc., right. So these are the two cases we need to consider. So let us first take if the mass is large. If the mass is large, then what happens? See, lambda becomes very small. It becomes so small that it becomes very difficult for us to measure it. So as it becomes so small, it goes beyond measurement. Okay, it goes beyond measurement. So as it goes beyond measurement, so then as we cannot measure the de Broglie wavelength of a large mass, we are not going to consider de Broglie wavelength for car, bus, cricket ball, this kind of things. We are going to consider de Broglie wavelength for electron, proton and neutron. Now I hope you must be clear in the first. Yes, here I have written electron, proton and neutron, and I had not written like car, bus or something like that, or even myself. Okay, so basic part of equation is done. Now there is a case in which if the electron is accelerated, if the electron is accelerated by a potential difference, so there is a relationship that will help us find out lambda or wavelength in terms of the potential difference between two plates and also mass of the particle. So that thing we are going to derive it now. Okay, so you can write the heading as de Broglie wavelength of electron. Specifically, if you are taking electron, okay, and it is accelerated. It is accelerated electron. Okay, so how this is accelerated? Let us see this. So these are two parallel plates. So here it is positive charge. So I am giving potential difference, and here it is negative charge. The potential difference is V. Okay, so here there is a electron which is initially at rest. As soon as it comes in vicinity of these plates, the potential difference works on it and it accelerates this electron. This electron gets accelerated. This electron gets accelerated. So much so, its final kinetic energy becomes half mv square. No problems, it can become. Now the initial kinetic energy is 0 because the velocity is 0. Its final kinetic energy becomes half mv square. Each and every one of us know something called work energy theorem, in which it has been said that change in kinetic energy is brought about by the work done on the system. So here what is the change in kinetic energy? So you will say the change in kinetic energy is change in kinetic energy is equal to work done. This is work energy theorem, right? So here the change in kinetic energy is half mv square minus 0. So I will write only half mv square over here. Next, work done. Here the work is electrical work. It is done by charge, and it is done by charge, basically potential difference on the charge. So what is the charge? Charge into potential difference is electrical work. Electrical work is charge into potential difference. What is charge of the particle? Electron's charge is E. So I will write E. Capital V, which is potential difference. This V and this V is different. This V is small v, this V is capital V. Many a times I have seen people cancelling capital V, small v. Don't do that mistake. You write this in such a way so that you don't do that mistake. Handwriting sometimes matters in life. Now this one can be converted into momentum. How? See, I can easily write this. Correct? I am multiplying with mass in both numerator and denominator. Clear? So this becomes p square, that is momentum square by 2m is equal to E. Now p will come out to be root over 2 m. This is another formula for momentum gained by the electron due to potential difference applied on the electron. I hope this is absolutely clear to everybody. Clear? Okay. Now what's next? The next thing is that we need to understand, if in a case, suppose in place of this electron there is another charged particle which is given, say, proton. So here there will be protonic charge, still it will be E. Suppose it is given as alpha particle. Suppose it is given as alpha particle. What is alpha particle? Alpha particle is helium 242 class. So alpha particle has a mass of 4 AMU or U and charge of 2E. So sometimes people face a little bit of problem while solving numericals when asked in this scenario. The problem can be completely nullified if we use this formula generally, that is P is equal to 2 m q v. So what you do is, instead of this E is only applicable for electron, but Q is applicable for any charged body. So use Q and everything is solved. We have to change the page. So what we have got right now is, we have got momentum is equal to root 2 mqv. Now what is lambda de Broglie? Lambda de Broglie is h by p. So h by root over 2 mqv. Okay. So now if you use it for proton, you use it for alpha particle, you use it for something else which is charge, you can just use its charge over here directly and you can solve the problem. Now on the basis of these two formulas, basically this formula, on the basis of this formula, I had checked in 2023, JE 2023, only I'm taking only JE 2023. But I have seen questions have been asked in 9 shifts. I may have missed 1 or 2 shifts question, but 9 shifts, so I can guarantee that in 9 shifts questions have been asked on this one. 22 also questions has been asked, but I am taking only 23. 9 shifts this question from this, direct question from this has been asked. Why I was talking about 2023? For de Broglie wavelength of electron, this formula can be also written as 12.3 by angstrom. This can also be written as 123 by root v nanometer. Based on this formula, direct question has been asked 2022. Bad question. If you ask me, this is a bad question, but this has come. We need to know these things also, because people who will be knowing this formula will be doing it in seconds. Suppose you have not done this formula, you don't remember the formula, then you may require a little bit of time, and quite a bit of time if you ask me, to find out this. okay, whether it is 12.3 or not. However, I will give you a shortcut for this because this is important. Suppose you don't remember this formula, then what you do? See, in the question it was given that Debroglie is 123 by x nanometer. Here the unit was given. So lambda, that's it for sure. Now it is given for a electron, that is also it is written that it is given for an electron. Now what is x? So there are different kind of things that are given in the bottom part of it. You know this formula is known to you. For electron also you know it, this will be just E. So suppose you know this value of H, so this H is definitely not 123. You know this value of M of electron, you can just in your mind you have to do a little bit of root and all, that much you need to do, and you can get a quick idea that this to get this kind of value in nanometer you need to have this as root V, nothing else, because everything else is known. Either it will be root V or it will be V, maybe, even if you forget, but it will be root V because in formula it is root V only. Okay, but better to remember this formula directly because otherwise you guys will be facing some problems. Okay, so this is what Debroglie is. This is what Debroglie equations are. How to apply these equations? Many questions, this has been a important formula that can be used directly, that is root 2 is constant. In many questions either mass has been changed, charge has been changed, voltage has been changed, and they have just done these things, nothing else, just done these things. So suppose mass has been changed, only mass, so other 2 is constant, so lambda dB 1 by lambda dB 2 is equal to root over, only mass has changed, so M2 M1, this kind of thing. If both, suppose if Q also have changed, Q1, if voltage also have changed, no problem, V2 by V1, done, that's it, nothing else. So you need to do this time and time again. You need to solve lot of numericals because this kind of numericals will come and you need to do them in 10 seconds, maximum 10 seconds, not more than that. So with that I end today's class for Debroglie equations, and we are going to take some important numericals on this in our next class.